Continue seeing Apex in action. In this case, we actually going to be showing how a user gets to execute a bat file, a bat program. Let's say that he got that from a USB key or any other means of automatic running. But when he does that, we're going to see that his machine gets in direct communication under the control of the dark comet, as we shown before. On the copy of the very same machine that only has Apex as a difference, we're going to see what difference that makes. That process, that communication with the bad guy, it's going to be actually blocked. Let's see that in action. Here, same setup. The good guy goes and execute on that program. So here we're going to execute it manually, and bingo. His machine has been compromised, and we can do the very same things that we did before. So let's actually close the server. Let's do the same attack, the very same image with Apex. And you know, whitelisting will miss that one, of course, but in the case of Apex, when you click on it, I can be clicking on this thing all day long, and there's that process will not be allowed to do communication with that botnet, because we know that that's not what applications normally do. So we know how to actually block that. That's an error message on that comet. Nothing to do with the demo. So I hope that proves that point. Let's see another one. This second case is even more pernicious. I mean, this is a case in which a bad guy takes the Internet Explorer code, replaces the Internet Explorer code with his own code, which is malicious, and actually is the one that performs the communication with the Dark Comet tool. And it's very interesting because we're going to launch Task Manager, and we're going to see that to the operating system, that's IE, that's Internet Explorer, looks like Internet Explorer, and you know, any whitelisted solution will miss this one entirely, and antivirus and all things cannot detect this type of attacks. We're going to then do the same thing with Apex, and we'll see that communication never takes place, because that process is not even allowed to run, because it knows that IE does not behave that way. So let's see that in action. So here we are, and we're going to launch this other attack, which is actually the one that performs that hollow process, and bingo, the machine gets actually compromised, as we've seen before. And actually in here, if we launch the Task Manager, we see that Internet Explorer should be running here, and yeah, sure it is. It's here, Internet Explorer. What are the giveaways if you were looking for it? Well, Internet Explorer will never run in such a small amount of memory, and also I don't see any active window for Internet Explorer in here. But yeah, you know, you need to be looking at that, and ordinary users will not, and unsuspected users will not either. Let's do the same thing. Let's actually close that communication on the rat tool. And let's do the same thing with the guy protected with Apex. So if we double click on the process, we actually see, I mean, let's do it again. We can click as many times as we want, and we see that there's no communication with the bad guy, so we are protected. Let's see when we open Task Manager, what is it that we see? We don't see IE running, because it knows that it knows how to stop that. Notice that actually from the previous attack, that process, that rat command executable, and this rat hollow process is actually running. I mean, yeah, that's fine. I mean, you can have some things that are kind of contained, because no communication, and that's the beauty of Apex, no communication is allowed to go with the bad guy. We don't see any instance of IE, because it knows that IE doesn't behave that well. But these two programs were running from before, but they are completely contained. There's nothing bad that they can actually do.